just want to harass my students so while they're sitting here in a minute. All right, so we're going to go through, we already did the transformation matrix. I'm sorry, the translation matrix. Once again, a transformation matrix is basic to anyone who's played 3D games or 2D games, going all the way back to RuneScape. I think I have some students, this will be more fun when people are in here. Some students play RuneScape, some students play Sims. My daughter plays Sims. And this is going to make a lot of this use of computers much more exact. It's going to help with GIS, all the coordinate stuff you did. You've done this in the past with a program called Wolfpack. Wolfpack is not designed for doing it on large transformations of 10,000, 20,000, 30,000, 40,000 points, which is what starts to occur in something called point clouds. All right, so remember our transformation matrix is built like this. We start with a identity matrix. That's your identity matrix. You fill it up with zeros along the bottom and a 1 placeholder here. And this is your translation. So if you want to move something 10 in the x, 10 in the y, and 10 in the z, you multiply that matrix by the matrix of your point. And in this case, we'll talk about 4 points in a second here. We'll do 1 point today. If this is our x, this is our z, our y goes into the board, a point that is 10 in the x, 0 in the y, and 10 in the z looks like that. We'll put that here, 10, 0, 10, and we pad that with a 1. We multiply this by that, and we will get that point transformed, which is going to be 20, 10, and 20. That's what that turns out. If you plug this into your calculator, this in matrix A, this in matrix B, you multiply A by B, you get that point. That's the transformation matrix for a translation. If we are going to be talking about typical sections or anything in 3D, we're going to be rotating around the x-axis, which is called pitch, the y-axis, which is called yaw, and the z-axis, which is called yaw, and rolling is going to be about the y-axis. We're not going to be doing rolling in civil stuff except when you get to super elevation. So we're not going to ignore that right now. We're going to ignore that right now. We're going to put in our heads, put the fact that x and z transformations are going to look the same, but the y transformation is going to be a little bit different. If we want to rotate about the x-axis, in other words, flip something down, we are going to hold these numbers constant. And into the remaining 4, you're going to put a cosine function, a sine function, a sine function, and a cosine function of the angle that you are rotating. Once again, you're going to put a cosine, a sine, and a cosine, and it'll either look like this with a minus sign here, or it'll look like this with a minus sign there, depending on what you're doing. The last thing you've got to do is you've got to realize that you're going to want to learn to either experiment. I would say experiment with a shape that's not just a single point. We're going to experiment with a W shape, because when we flip the W shape, we lose all of our Y's and they show up as Z's. And so what you have to realize is whether this angle is positive or negative is going to be most probably best done by kind of experimentation and asking a question you know the answer to. So before I stick this thing out on YouTube, I'm going to ask Justin here, who just happened to walk into my TV studio, what's a tangent of 45 degrees? Is that? Good. And I'm going to ask Kaylee, you guys, I'll cut this out, you guys. Kaylee, what's the cosine of 45 degrees?
-1. -1.
Cosine
0.
of 45 degrees is the square root of 2 over 2. So I'll end this video with this general bit here. Remember this, all in TV land. No, just kidding. You remember this? 0, 1,
Are you
1,
acting?
0, 0, minus 1, and minus 1 and 0, and the rest of these.
Go Packers.
Remember those? Over 2, over 2, over 2, over 2, over 2, over 2, 1, 2, 3, 1, 2, 3, square root of 1, square root of 2, square root of 3, square root of 1, square root of 2, square root of 3. What's the definition of cosine? It is x over r. The radius of that circle is 1, therefore it's the square root of 2 over 2. Now that you know the tangent of 45 degrees, Justin, learn the cosine and the sine as being 0.707, the square root of 2 over 2. If you do not see those, you're going to see those come up so often, it makes it a lot easier. If you're punching your calculator for some of that stuff, you're going to be in trouble. All right, so what you're going to be doing finally, like we talked about it, if you're rotating about the x-axis, that is called roll. I'm sorry, this is called pitch. Remember, x, y, z, pitch, roll, yaw. What you've done up till now in 2D flat work has been all yaw, which is rotation about the z-axis. All right, so again, you keep the matrix here. You plug in a cosine, sine, minus sine, cosine. These things will be switched. You don't have to completely have it in your head because you're going to experiment. Experiment so you can get the function correct. Thanks for listening. Yeah, well, we got sound effects. We'll leave that. YouTube people, you're going to love this class.